All right, let's get right into it. Today, we're going to tackle one of the absolute cornerstones of React, state management. We're going to demystify how React actually handles data, which, as you know, is the key to building those really dynamic, powerful web apps we all want to create.
You know that feeling when you're using a web app and everything just works? You click a button and something updates instantly. No annoying page reloads, no waiting. It just feels fast and fluid. Well, that's not magic. Not at all.
A huge piece of that puzzle, the secret sauce, if you will, is right here. React's whole component-based architecture. The big idea is to build your entire user interface out of these little, self-contained, and totally reusable blocks of code. So that brings us to our first big idea, components. Honestly, if you want to master React, this is ground zero. It all starts here.
So what exactly is a component? Well, think of it as a reusable Lego brick for your UI. It's a self-contained piece of code that handles its own logic and its own look and feel. It's kind of like creating your own custom HTML tags, but with superpowers. You build these little bricks and then you snap them together to build something amazing and complex.
Okay, but let's be real. A component that just sits there showing the same static text forever, that's not very useful, is it? To get those dynamic experiences we're all aiming for, our components need data. They need information that can actually change and react to what the user is doing. And that brings us to the main event, the heart of our topic today, the two fundamental ways that React components get and manage their data. You've heard their names 1,000 times, props and state. I absolutely love this analogy. It just clicks. Think of it like this. State is the component's own memory. It's what it remembers about itself, like whether a button is toggled on or off. Props, on the other hand, are like instructions handed down from its boss, the parent component. So state is internal memory, props are external instructions. Simple as that. And this table just lays it all out perfectly. You can see here, props are passed down from a parent, and, this is crucial, they are read-only. The child component can't just decide to change its own props. It's like, here's your data, don't mess with it. State, though, that's a different story. It's managed inside the component itself, and it's totally mutable. It's designed to change over time, maybe when a user clicks something. So a component owns its state, but it only receives its props. Okay, so state is obviously super important, but how do we actually use it in modern React, in our functional components? Well, that's where hooks come into play, and specifically, the king of all hooks, useState.
Yeah, a little history lesson is actually pretty helpful here. You see, back in the day, and I'm not talking that long ago, if you wanted a component to have any kind of state, you had to write it as a more verbose class component. But then React 16.8 came along and, no exaggeration, it completely revolutionized everything with the introduction of hooks. Suddenly, our simple, clean, functional components could have state. It was a total game changer.
So what is useState? At its heart, it's just a special function that React gives you. It literally lets you hook into React state management features from inside a simple function. It's how you tell React, hey, I need this component to remember something. And this line of code right here, you are going to see this everywhere. It's probably the most common hook you'll ever write. Now, I know if you're new to it, that syntax with the square brackets might look a little weird. It's called array destructuring. But trust me, once we break it down, you'll see how elegant and powerful it really is. Okay, let's pull this line apart. It's basically three key pieces. One, the state variable itself. In this case, it's count, and it holds the current value of our state. Two, the setter function. We're calling it setCount, and this is the only way you should ever update the count value. Don't just try to assign a new value to it. And three, the initial value. That 0 inside the parentheses, that's what count will be the very first time the component renders. All right, so we've got state handled inside a single component. That's great. But what happens when your app grows? What if you have components way over here that need the same data as components way over there? Well, this leads to a super common headache in React development. And it's called prop drilling. The name is pretty descriptive. Imagine you have to pass a piece of data from the top of your app all the way down to a tiny button component like 5 levels deep. You have to pass it as a prop through every single component in between, even if those middle components couldn't care less about that data. They just become glorified messengers. And this is a perfect example of what that looks like. Let's say our top-level app component has the state maybe for the logged-in user.
But the component that actually needs that user info is the user profile component, which is way down at the bottom. To get it there, we have to drill it down through layout, then through sidebar, and neither of those components actually use the data. It just makes your code cluttered and a real pain to refactor later.
So, this prop drilling thing is obviously a problem. How do we fix it? Well, luckily, the React world has given us two really solid patterns to solve this exact issue.
On one side, we have a technique called lifting state up. This is more of a fundamental pattern, a way of thinking about your component structure. And on the other side, we have the context API, which is a powerful, built-in feature of React that's designed to solve this problem more directly. The trick is knowing when to use which one.
So lifting state up is usually the first thing you should try. The idea is simple. If you have two components that need to share the same piece of state, you find their closest common parent in the component tree. You then move the state from one of the children up to that parent. From there, the parent can just pass the state down as props to both children who need it. Problem solved.
So, when should you reach for this pattern? Well, it's perfect when you're just sharing state between a couple of components that are pretty close to each other. You know, when your component tree isn't super deep. It's also great because it keeps your data flow really explicit and easy to follow. You can literally trace the props down the tree. It's clean, simple, and often all you need.
But what happens when lifting state up means lifting it way, way up and you're back to prop drilling again? Well, that's when you bring out the big guns, the context API. The best way to think about context is like a data teleporter. You create a provider at the top of your tree, and then any component, no matter how deep it's nested, can consume that data directly. It just bypasses all those components in the middle.
Yeah, this is your go-to solution for avoiding really bad prop drilling. You want to use this for data that's considered global for a big chunk of your app. Think about things like the current theme, light mode or dark mode, or the currently logged in users data, or maybe the language setting for the whole app. For stuff like that, context is absolutely the right tool for the job.
So let's wrap this all up into a simple decision-making guide. Here's the mental model you should have. Rule 1, always start by keeping your state local, right inside the component that needs it, using useState. Rule 2, if siblings need to share that data, lift state up to their closest common parent. And rule 3, only when prop drilling becomes a real problem, when you're passing props through multiple layers that don't need them, then you should reach for the context API.
So that leaves us with one final thought, a question for you to take back to your own code. The next time you're starting a new feature and you have to decide how to manage its state, are you going to lift it up or are you going to use context? It's not just a technical question, right? The answer really shapes how clean and maintainable your application is going to be down the road. So think about it.